essentially means that if I have something like 3 to the x plus 4 is equal to 3 to the 2x plus 6. Those two have the same base. And because they have the same base, then their exponents have to be equal. So if 3 to the x plus 4 equals 3 to the 2x plus 6, x plus 4 then has to equal 2x plus 6. So now we've got it just down to a simple equation. Subtract x from both sides. Subtract 6 from both sides. You end up with negative 2 is equal to x. And if you plug negative 2 back in there, negative 2 plus 4 is 2. Negative 4 plus 6 is 2. You get 3 squared equals 3 squared. Okay, so if the base is exactly the same, it's whatever. You just set the exponents equal to each other. And that's easy enough. The problem, of course, becomes when we start changing so that the bases aren't necessarily the same. So if we have something like 1/2 to the x plus 7 equals 4 to the 3x. Now their bases aren't the same. So what we have to do then is we have to think, okay, what base, how could I manipulate this 1/2 and this 4 so that I don't change the value, but they have the same base? Well, 4 is just 2 squared. So I could change that 4 into 2 squared. That hasn't changed it. Now I've got a base sitting there of 2. And if we follow our rules of exponents, when you have an exponent to an exponent,
it goes to the 6.
Okay, so this is 2 to the 6x. Now we've got the half. How do we make a half a base of 2?
Didn't we already use that half?
Nope, we haven't done this side yet. So 1/2 is the same thing as 2 to the negative 1. 2 to the negative 1 is 1/2. So now we still have the x plus 7 sitting up there. So again, if we go power to power, that means I have to take negative 1 times x. So this is 2 to the negative x. And I also have to take negative 1 times 7. Now we've manipulated those so that they have the same base. Now that they have the same base, we can just go ahead and set the exponents equal to each other. So negative 7 equals 7x. Add x to both sides. Divide by 7. And get an x value of negative 1. And if we plugged that in there, it would work. But if the base isn't the same, one of the ways we can do this is we can manipulate it so that the base is the same, and then we can go ahead and solve. And that's not the easiest thing to do all of the time. Okay. So any questions with that one? Again, there's going to be lots of questions. It's hard. Okay, today is not going to be one of those easy days.
It's not?
No.
Is this assignment on a piece of paper or not?
Your assignment's not as bad as the notes are going to be. Okay, so let's look at the second one. Let's look at 25 to the 3x is equal to 125 to the x plus 2. So if I look at thinking about what a base could possibly be. You have to switch it. Well, in some cases you can switch one, in some cases you have to switch two. We have to have a common base, and we got to figure out what's a common base with 25 and be 5, right?
Yeah.
25 is 5 squared. 25 is 5 squared. So this is going to become 5 squared to the 3x. And the biggest part of this is you have to remember that you're squaring things. You're not taking it times 3. Okay, because if you take it times 3, then you're not changing this base. That base is still 25. Okay, it's not, remember, we got to go power to power. Okay, so that side then makes 5 to the 6x. So that side is 5 to the 6x. 125 is 5 to what power?
To the third.
5 to the third. 5 to the third is 125.
So it's also 5 to the 6x.
No. So this is going to be 5 to the 3x plus 6. Because remember, now you're distributing. The 3 times the x is 3x. You get 6. Now they have a common base. Now that they have that common base, our exponential, our property that we talked about of equality says that the exponents now have to be the same. So 6x is equal to 3x plus 6. Subtract 3x from both sides. 3x is equal to 6. X is equal to 2. And that's your solution for that one. And you're essentially done. Questions with that one? Yeah.
So, like, don't put lines anymore, it would be like they're separate.
Because they're bases. It's different than 25 times 3x is now to a power. Let's look at 6 to the x minus 2 equals, hang on here, sorry, didn't give me what I wanted it to. $216. Okay, so we want to use this using the property. So as I'm looking at this, it's kind of what's going through the brain. 6. Can you break really 6 down? It's anything squared 6. No, there's anything. So let's look at 216. 216 is 6 to the third, I think. Okay, so 216 is 6 to the third. So I could rewrite this as 6 to the x minus 2 is equal to 6 to the third. And they have a common base. So then x minus 2 equals 3, x equals 5. So if you can manipulate it so that common base is the same, hard, but kind of doable. Now what happens if we get something like this? So if we have 3 to the x plus 1, you're going to want to put your phones away because this gets really hard. So we got 3 to the x plus 1 equals 5 to the x. There's no way to make these bases the same. Okay. We can't make these bases the same. So we've got to go about this bit of a different way. So just like when you add something to one side of an equation, you can add something to the other side of the equation. You can do this with logs as well. If I add a log to one side of the equation, I can add a log to the other side of the equation. So the first thing we're going to do with this is I'm going to change, and I'm going to make this log base 3 of x plus 1. And I'm going to make this log base 10 of 5 to the x power. So we've got log base 10 of 3 to the x plus 1 and log of 5 to the x power. Okay. So go back to yesterday a little bit and rewrite that. So go back to what we did yesterday and rewrite it and then stop. So the properties that we talked about yesterday, this isn't, we can change those a little bit. Change them a little bit. So go back to what we did yesterday. If you're to a power, if your of is to a power, where does that go? Just write it down. Don't answer it out loud. Don't answer it out loud. Just write it. Okay, so remember where we started. We started with two bases that aren't the same. We added the log in there, and as long as we do one to the one side and one to the other, we're in good shape. So our properties from yesterday said that if we have it to our of to an exponent, that I can take and rewrite that as x plus 1 times the log of 3. And then this is going to equal x times the log of 5. Everybody remember doing that? Okay, so that was yesterday. Okay, now algebra from the 6th grade. You learned the distributive property in 6th grade. I can take this left-hand side now, and I can rewrite this left-hand side as x times the log of 3 plus the log of 3. I'm just taking this log of 3 and distributing it into both places. That's going to equal x times the log of 5. There's an answer in there somewhere. Oops. This here and this here both have logs, both have x's in them. So I'm going to get them on the same side of the equation. Just like you would if you had 3x and 5x. Because we've got x's in both of those, we're going to put them on the same side of the equation. So I'm going to go ahead and subtract x times the log of 3 from both sides. Now, this gives me log of 3 is equal to x log of 5 minus x log of 3. I can't take 5 minus 3. The ofs don't match up. So since the ofs don't match up, I can't subtract.
So that's the answer?
No, we're not done. We got to solve for x. The whole thing is to solve for x. We got to figure out what this x value is. Anybody have any thoughts what we could do next? What does that left-hand side have in common?
Put it in your calculator.
What does that left-hand side have in common?
The log of
Say the first part. They have an x in common. So if they have an x in common, I can take out an x. I can take out a GCF. So if I take out the GCF on that right-hand side, that gives me x times log of 5 minus log of 3. We have to solve for x. So when you put two things beside each other, it means to multiply, right? So how do you get rid of multiplication? Divide. So now I'm going to divide both sides by log of 5 minus log of 3. So now on the right-hand side, log of 5 minus log of 3 divided by log of 5 minus log of 3, that all just goes away. So on the right-hand side, we're left with x. All of these things here, log of 3, log of 5, log of 3, can you find those on your calculator? Yep. You can find those numbers on your calculator. But before we do that, let's go back to yesterday. You could do this like this now and just start punching things in, and it would work. But we might as well talk something we talked about yesterday. Could I rewrite this?
Yeah.
Yeah. What does that rewrite as? Log of 5 over 3. So we've got our original. So here we're kind of getting close now. So we've got our numerator, log of 3. The denominator now becomes log of 5 thirds. So when you subtract, you divide. So now on your calculator, log of 3, close the parentheses, divided by log of 5 divided by 3, close parentheses. And you all say math is like the greatest class ever.
I don't think we've ever said that ever.
Why not? You got a number. 2.15? X is equal to 2.15.
Who did that?
Yes, probably is the correct answer to that. Mathematically, I would agree with your statement. That's probably the most complicated thing. Proofs are pretty tough.
Proofs are so
Algebraically, probably the hardest thing you've done. Proofs?
Bro, this is still okay. Algebraic proofs are okay.
Algebraic proofs are okay. Geometry proofs, not so much.
No.
All right, let's look at. That's a lot. I get it. It's a lot. But we had so much fun with it. Let's look at this one. Now, we're going to do this together. I think Jude probably figured out how to do it an easier way. Right?
Bro, how?
Okay, so now there's a reason I put this one up here. 90% of you right now are just going to go and revert back to what we just did with all that log mess, right? Is that where you were going?
No, I was just not gonna try.
Or you just weren't going to try?
Wait till you do it.
No, so 196.
Is it 14 squared that?
So a little more than, so it's 196 is 14 squared.
Oh.
Okay, so always look first for the easy way. Mathematically, that's kind of the game. Always look for the easiest way to do it first. If you can't do it the easiest way, then do it the hard way. Both of them work. We are going to do it the hard way.
What? I already finished the easy way.
Because I want you to practice doing the easy way, the hard way. Okay? Now, if this was on an assessment and all you had to do was find the value of x, you darn well better use the easy way. Does everybody know the easy way? It'd be 2x plus 7 equals 2x plus 4. No.
No, because you have to.
X plus 7 equals 2x plus 4. X plus 7 equals 2x plus 4. Because 196 is just 14 squared. So that's the easy way, but that's no fun. So let's do it this way.
Yeah.
So let's go log of 14 to the x plus 7 equals log of 196 to the x plus 2. Make sure you have room. Okay, first step for everybody, and then stop. Rewrite the next one. Rewrite this using the properties that we talked about yesterday. Okay, so rewrite it using the properties we talked about yesterday, and then stop. We all love math. Some of us do. Okay, peek up, make sure you've got that part right. Now distribute it. So now distribute the log of 14 into the x plus 7 and distribute the log of 196 into that mess over there. And then stop. Okay, so do the distributive part of it and then stop.
So the next step, you have to mind it.
So we should have x times the log of 14 plus 7 log of 14 equals x times the log 196 plus 2 log 196. Is everybody okay?
Yeah, we're good.
All right, so I think Mr. Gary back there said we've got x's now both here and here, right?
Yeah, I said that.
Okay, so if we think about what we've got going on, you think about what's going on, it's not that bad. Put it in terms of if it was just regular numbers. This log, 7 log of 14, that's just a number. It's an ugly number. It's actually a really big number, but it's just a number. This here is just a number. That's all those things are.
Wait,
Think of this as 3x and think of this as 2x. It's not, but you could think of it that way, yeah.
could you put it in your calculator right now?
You could, but you're going to have rounding issues. Because this, and putting this number in the calculator, it's big. Okay? So instead, which way do you want to go? Subtract 14. Let's subtract x times the log of 14. X times the log of 14. And then I'm going to subtract 2 times the log of 196. Now understand that none of these things cancel out. They're all separate things. So we've got 7 log 14 minus 2 log 196. We can't combine them because they have different ofs. Equals
X log 196
x log 196
plus minus X log 14.
minus x log 14.
Look at that.
Look at that.
And now we need to start doing some division up in there.
Now we need to start doing some division. But let's take this left-hand side now. Let's take this left-hand side and let's write it as a single log, like we did yesterday. You were able yesterday to take this and just write it as single logs. Most of you just looking at it and saying, I can do this now. That means we're going to subtract. That means we're going to divide. That means this is going to be 14 to the 7. Okay? So, if we rewrite this, it's going to be log of 14 to the 7th power over 196 squared. Correct? I do, though. Equals. Could factor out an x. So then this leaves us with log of 196 minus log 14. Okay. We're close. So we've got log of 14 over 7, 14 to the 7th, 196 squared, divided by what?
X log 196
We're
minus
leaving the x over there.
Oh,
We're leaving the x over there.
my fault.
So it's going to be log of 196 over 14. Remember, we're dividing this
By its reciprocal.
by log of 196. There shouldn't be a parenthesis there. We're dividing both sides by the log. 196 minus log of 14. That's equal to our x. So calculators, this works on your calculators. You gotta be careful that this works on your calculators. Hit log. If we did this all right, it works. I think that makes it work. So you gotta go log 14 caret 7. I'm hoping this works. The underneath pi symbol. Divided by 196 squared. Close the parentheses. Divided by log 196 divided by 14. Close parentheses. Press the button and parade says 3.
That's so satisfying that you did that on Preston.
Look at that. Now, it's painful. Okay.
No way that
Yeah. And it made sense from the beginning, right? We said that this is just 2x plus 4, and this is x plus 7, so it worked out both ways. Okay? Now, as you're going through the problems today, you only have 4 of them. Okay? Nothing even close, I don't think, to what these are. Okay? But sometimes we do things for the challenge of it. Okay? And something that looked god-awful when I first did it, when we did this one up here, we were understanding what was going on down here. And the way we did this one, that's hard. There's a lot of places to mess this up. And a lot of log stuff and exponent stuff that you have to take care of as you're doing this. Okay? So you've got 4 problems today. Questions 1 through 4 on that worksheet. I think we covered it all. I don't even know because I haven't really looked at those 4 questions. But I think they're just like the top ones. Like the easier ones. We had a whole lot more that we were going to do today. But that was so much fun that I thought we'd do that instead.